Hello, David here, and the project for today is brazing aluminum. I never knew you could braze aluminum until I needed a project where I had to repair a piece of aluminum, and I watched a YouTube video from Project Farm. This guy's an engineer who does lots of amazing videos. I suggest you check it out. He tested all the different types of aluminum brazing rods and discovered that Hobart performed the best. So I bought this Hobart aluminum brazing rod. It's a 1/8 inch diameter rod. Before I go any further, let me discuss the difference between welding and brazing. Brazing is very similar to soldering. When you're welding, you are pretty much welding the base material, and you're actually melting it, and then you're adding some filler rod and mixing it together, and then it cools and sets, which is the best method of repairing stainless steel, carbon steel, and aluminum. If you don't have that equipment, for which you'll need a TIG welder or a MIG welder, this is the next best step. And all this does is this heats the material, and it gets it hot enough so that the material will melt the filler rod. So the subject material doesn't melt, it just gets hot. And just like brazing cast iron, this will braze aluminum with the filler rod. Just gets it hot, melts the rod, and then the rod melts into the two pieces of aluminum. So you don't need a torch. You can use a propane torch. You have to heat the base metal to 700 degrees Fahrenheit. You don't heat the rod, you just heat the base material. And when the base material gets up to 700 degrees, that will melt the rod. If you try to just melt the rod, the base material will probably be too cold, and the material will not bond. Let's talk about prep. I know when you're welding, you have to clean the scale off the metal. Same thing with aluminum. There's oxide on aluminum, and you have to brush it. So I have this stainless steel brush here. It's never been used before, and you cannot use it on carbon steel and then move over to aluminum. If you do, you'll get impurities into the stainless steel, and that impurity will ruin your weld. I assume it's the same thing with brazing. I'm not going to take any chances, so I will be brushing the oxide off the aluminum, and then I'm going to clean it off with some acetone to make sure there's no oils in there, which will give a good bond. So once I use this brush, it's going to be dedicated for aluminum only and nothing else. By the way, if you brushed your aluminum yesterday and you're going to weld or you're going to braze the next day, you're going to have to brush it again because this oxide layer comes back almost immediately. It's about 360 degrees. Let's let it cool before I test it. Okay, it's cool enough to handle. I was able to do both sides. When I did the back side, the front side didn't melt away, which that was something I was afraid of. I did miss a little part over there where there's a void. Come on. Starting to come away over here. You can see that gap in there. And I didn't have full contact when I cut this piece of aluminum. It wasn't perfectly straight. That might have been part of the problem. It is taking all my strength to pull this away. So that's a pretty good bond. You're not going to tow a Kenworth if you repair a trailer hitch. But this is a good alternative to TIG welding on parts that are not going to take a lot of stress. Alright, here's my second coupon, and what I've got is a 1/4 inch plate aluminum, and this is pretty much approximates my brazing project. I have an oval cut in the plate, and then I have an oval filler that I'm going to braze inside my plate. So this is going to be our test, and I have my friend Spacer X here.
Racer X.
Oh, I'm sorry. I have my friend Racer X here, and he told me that that centerpiece might float. So we have a little piece clamped. You can see my hookup here. I have a clamp to a clamp to provide some downward pressure on that inside piece. So let's bring that thing up to temperature. It took me about 2 minutes, maybe 4 minutes to get that temperature up. I'm 41.
Let it heat up a little more, Dave. It's not hot enough yet. Temperature?
295.
It has to get up to 7. Right?
Right.
These are cold solder joints. That copper bar on the bottom is really a good heat sink.
Maybe it's taking all the heat away.
Yeah. You're out of gas. Okay. Oh, you good?
Still running. But I am close. It's slow.
Temperature check. Should be pretty hot by now. Huh?
Let's try dipping it again.
Oh, something's happening with the aluminum. I see the color change. It's melting. You see that? You see that phenomenon?
Yeah.
All right, it's getting up there. Can you do a temperature again, David?
Yeah. 331.
Okay, we're halfway there. It's working though. See how hot it's getting right there?
Yeah.
That's because it's thinner there, I think. Or
That was in that other video where it was making a pool.
Yep. So you don't want to put this stuff in until it starts to get hot. Otherwise it'll do what's doing here. Now when that starts to do this, that's when you know inside the joint. Temperature check. Wow, it takes a while. Is that centigrade or Fahrenheit?
Fahrenheit. I think that copper must be drawing a lot of heat off.
Yep. You want it? Let me see. Let me put a little bit in here and we can take the copper off, okay? So you want to just do it locally there. Let it go down into the crack.
Just run it all the way through.
Just run it?
Yeah.
Okay. to wrap.
That took a long time to heat up. It could be because of the 1/4 inch thickness of the plate.
And also the backing, copper backing.
Okay, it's still hot, but it's cooled down some. You can see what it looks like. We have a void right here,
Shrunk.
and it shrunk. Yes, the
filler
aluminum
shrunk.
The aluma weld did shrink in the groove. Let's look at the back side. We were expecting to see some aluminum filler migrate around the sides to the bottom, but that really didn't happen. We do have some filler down here, and that probably came out when I did that first part. If you remember, on this end, a lot of filler just kind of melted in there, and we were heating this up for a long time with that aluminum filler in there, and I think it must have migrated out at that time. But
How hot was that piece? About 390.
I think it was about 380 or 390.
Okay.
This big piece of copper, there's a copper bar here that we used as a backer. I think that took a lot of heat out of this.
This bar.
This copper bar, it's still very hot, but it's a huge piece of copper, and that acted as a huge heat sink.
1 inch thick.
But we did expect to see the aluma weld in the underside of this groove, and it really didn't happen. Okay, we're working on the same sample now, and what we're going to do is we flipped it upside down, and we're going to heat it up and try to get some of the aluma weld to migrate into that thin crevasse in there.
On the opposite side, right? You see it was floating that's why you need to put pressure on it.
Ah,
Now it seems like it went down there a little better, right? It did here, but not here.
now you can see it shrinking
Yeah.
in the crevice, and I'll bet a lot of aluminum has fallen out.
Yeah, you know, and it floated. You got to keep pressure on it on the top, otherwise it'll sink.
Uh-huh.
You need something like long, and we can put pressure on it, and we can put a weight on it or something,
Uh-huh.
because otherwise it'll start floating and it's not going to be good.
That's going to be hard to work in that pocket.
Yeah. So we'll do it 2 ways. We'll first do the inside, and then we'll flip it over and do the outside. That's the only way to do it.
Think so?
I don't know. You think it's better to just do
I
the
don't
outside?
think there's enough clearance in there to really concern ourselves with it.
Okay.
You know, I think we should just get a good bead on the inside,
Uh-huh.
and then once it cools and we're done machining the part, then I could push some JB weld in there,
Mm-hmm.
because that's going to survive the paint.
Okay.
The curing of the paint's going to be 300 degrees. So,
You want to turn?
okay, that's the side that was the underside. Now in the second go around, that's the top side. So let's see the bottom of that, and
How much went out?
you could see a lot of the aluminum. Bring it down into the frame,
Sorry.
right there. You could see the aluminum
Flowed through.
has flowed out.
Mm-hmm.
So you get it too hot, and you're going to lose your aluma weld. And I really think for my application, I should just do a one-side application on the aluma weld and get a really good bond. There's a good bevel on the plug, and there should be a lot of surface area catching the plug. And that piece isn't going to take a lot of pressure. There's only a spring that runs across that plug, which maybe has 10 pounds of pressure at the most, and it's going to take a lot more than 10 pounds to knock that plug out of that plate. Okay, here's a coupon. Cut it in half. It's still a little bit warm. Now you can see, okay, it's not focused. There we go. You could see where the plug floated, so it's not flat. So that's not going to be acceptable for my application, and I'm thinking of TIG welding for my application. And you could see penetration on this side of the aluminum. Aluminum flux did not get full penetration on that side, and you could see where it shrunk. I think one of the keys to take away is it does have a application for certain uses, and also you can't keep the heat on it all the time because you're going to lose your flux. It will drip away. And here's that piece where we didn't get full penetration, and you could see on the edge got some penetration at the bottom, but the heat drew the aluminum flux in, and it didn't really sit on top of the plug. Let's try to tear the plug out. Wish I had a way of measuring the poundage that I was pulling on this. Come on. Hey boys and girls, this is not coming out easily. Let me get a hammer. Dang, that's in there good. You know, this is testimony to the Hobart company for making a darn good piece of AlumaWeld. Mm-hmm. It hurts when you hit your hand with a ball-peen hammer.
I think you got it there.
You know, I think I ought to end the video right here before I kill myself.
Yeah. You like your hands.
Well, everybody, I want to thank you guys and gals for watching this video. It was a real learning session for me and Racer X. And we know what applications we can use this for in the future. And it's going to be a handy part of my tool crib. So I want to thank you guys and gals for watching. Don't forget to hit like, subscribe, and ring that bell for more great videos from David GPO. One more try.
Stop eating that thing.
Die!
It's amazing. It's amazing.
Here's some bonus footage. When Racer X and I saw the plug in that last coupon and how difficult it was to pound it out, we realized how strong this brazing rod was. And we decided not to TIG weld my final project, and we decided to use the aluminum brazing rod. So what we did wrong with that last coupon was, one, we had the heat on too long and all the aluminum oozed out. Plus we didn't have that plug clamped in properly, and it kind of floated up out of position. So I'm showing you the picture of the inside of the pocket where we plugged the gaping hole in the bottom, and the plug fit pretty well, and I didn't see any chance of anything oozing out, but I didn't want to take any chances. So we got the aluminum hot where the aluminum brazing rod would melt, and we kept it hot while we quickly melted the brazing rod inside the bevel of the plug. And as soon as all that rod was melted into the bevel all around the plug. We took the heat off and let it cool. Plus, we had a rod pushing down on the plug, clamping it to keep it from fluting away. And I'm going to show you the bottom side of what it looks like. That plug fits so tight, it almost looks like it's a casting line in the aluminum. Racer X did that, and he did such a great job. I highly commend him for his craftsmanship in finishing that plug. And also, one of my concerns was whether the product would warp, and I don't see any signs of any warpage at all. So that was a successful project, and my next step is to media blast it and Cerakote it. Thanks for watching. Bye now.